So good afternoon, everybody. So today what I'm going to discuss with you are the solutions of the problems that are primarily encountered in the STL files. As you might remember when we were discussing the STL file errors, the most common problem that you observe in an STL file is the missing facet problem. So after tessellation, slicing, and generation of the deposition path has been done, what happens is the solid model is recreated. The STL file is regenerated in the software, machine software. And during that process, what we generally encounter is that due to tessellation and this slicing, what happens is you observe some of the facets, they have suddenly evaporated or they have suddenly lost out. So suppose this is one surface which has been tessellated, and what you observe is that the facet 2911 and the facet 61214 has been lost. So these are the typical gaps that you observe in an STL file. So what you are actually missing is you have vertices V9, V11 and V2. The vertices will be there because they are the shared vertices of other triangles also. They are the shared of other triangles also. So they will be there. But the patch which will cover the surface is missing. So what we are going to do today is we are going to see the algorithm, how this algorithm actually works in order to identify the gap, how the gaps are identified, and then how these gaps are going to be filled. So let us see the solution of filling the gaps. So first what happens is all the facets that are there on the surface patch, all the facets that which are there on the surface patch, they are evaluated. Now how they are going to be evaluated? So if you remember when we were discussing the Mobius rule, what we had said was that every shared edge has an orientability which is opposite in direction on different facets. For a surface patch which is divided into facets, a common edge will have different orientability for the different surface patch. So this basic concept we are going to utilize in order to determine whether every facet, like facet A is over here, facet B, facet C, facet D, E, and F. For every facet, we are going to check for every edge. For every facet, we are going to check for every edge. And for every edge, we are going to check whether the edge is a shared edge. Now, if the edge is a shared edge, just like this, what is the orientability on the two facets of that shared edge? If that orientability is opposite, then the edge is valid. So let us start from facet A. We are starting from here. So this is the orientability. So the facet A has an edge from 2 to 3. Now this edge 2 to 3 is being shared with facet D. This edge is shared with facet D. Now when I check for the facet D, what I observe is the orientability is this side. So the opposite orientability of the same face is from 3 to 2. So for facet A, the orientability is 2 to 3. And for facet D, the orientability is 3 to 2. So that means the edge has a proper orientability. Now I will go to the second edge from 3 to 1. From 3 to 1. So for facet A, the orientability is 3 to 1. Now this edge is shared with facet B. So looking at the orientability of facet B, I check the orientability on facet B, and what I find is for facet B, the orientability is 1 to 3. So this means that this edge is also a valid edge. So now what I have understood is that this edge and this edge is valid. Now I'll check for this edge. So this edge is shared between facet A and facet C. So for facet A, the edge orientability is 1 to 2. Okay. And for facet C, the orientability is 2 to 1, which means that this surface patch, that is the facet A, is a genuine facet or it is a right facet. So facet A has been evaluated. Once I have done this, once I have done this part, I will keep on doing this process for all the facets which are there on the surface: facet F, facet C, facet D, facet B, and facet E. So first of all, so the first step is basically to check whether the edges, which is shared between different facets have a proper orientability or not. So this is the first step. Now, second step. Now, when I check for facet, I have to check whether the orientability is there or not. Now, suppose, let us assume that this is a gap. Let us assume that this is a gap. Now, what happens is between this, for this edge, what I check is at facet C, what I will check for is the orientability. So I am going to start checking the orientability over here. So for facet C, the orientability is 6 to 2. But the opposite orientability on the other face is missing. So this edge needs to be stored because this edge is missing the opposite orientability on the different facet. So now what we will do is we will keep checking for all the facets like this. For every facet we will check, and we will store the information in two different files. So we have one file which is called as file C, and we have another file which is called as file B1. File C, file B1, and there is another file which is called as file B. So file B will basically store all the edges which have opposite orientability. Okay, so file B will store all the edges which will have the opposite orientability. So that is your file B. Now you will shift to file C. Now what is file C? File C basically is a temporary file. It is going to be a temporary file which will store the information of the edge, which does not exist. Means here all the edges which do not have opposite orientability will be stored. So file C basically contains all the edges which do not have opposite orientability. As I explained in the previous slide, so 6-2 facet edge 6-2 does not have opposite orientability. So this information will go in file C. So for how will I store the information in file C? So file C will store the information of vertex 1 and vertex 2. That information is 6 and 2. So this information is going to be stored in file C. Now what is file B1? File B1 is basically that file which will contain the information of the missing edge. Contain the information of the missing edge. So as you can see from this slide, that 6 and 2 is there, but the opposite orientability is missing. So what is the opposite orientability? It is 2 and 6. So information of this 2 and 6, because this is the missing edge. This is the missing edge. So information of 2 and 6 is going now to be stored in file B1. So file B1 will store the information of 2 and 6. So in this way, the complete surface file with each edge, each vertex will be evaluated one by one. There is no set sequence for evaluation. You can evaluate it in any sort of sequence in random order if you want. But what you need to find out is file information that needs to be stored in file C and the information that needs to be stored in file B1. So what is file C? Again, I'll repeat. File C contains all the edges which do not have the opposite orientability. So 6 and 2, 6 and 2, from this example, 6 and 2, this part 6 and 2 is the facet or the edge of the facet which is missing the opposite orientability. So this information goes in file C, and file B1 actually contains all the information of the edge that is missing. All the information of the edge that is missing. So if you go back again to the same figure, what you observe is that 6 and 2 is there, but for the edge, opposite orientability 2, 6 is missing. So file B1 will include the information of 2 and 6. So in this way, we first of all find the edges which are missing, and then joining those edges, we form what we call as gap. We form what is called as a gap. Now, let us see this example. Let us see this example. You will understand it much better with this help of example. So in this example, what you see is that this is a gap, okay? And this gap is actually shared by lots of facets. This gap is actually shared by lots of facets: facet A, facet B, facet C, facet D, facet E, and facet F. So if you remember the first step is to identify all the facets, check all the facets for their edges having equal and opposite orientability. So now what I find is I'll create file B and I will create file C. So file B is okay. File B is all those edges which will be having opposite orientability. Like if I check this figure, so this edge will have opposite orientability, 1 to 2, and it will be 2 to 1. It will be 2 to 1. So this is having opposite orientability. Okay. So this edge is okay. Similarly, this edge is okay. But what happens to this edge? 2 to 3. 2 to 3 does not have opposite orientability. So 2 to 3 does not have opposite orientability. So what happens is, what we are missing is 3 to 2. What we are missing is 3 to 2. Okay. So what will the information of file C store? File C will store 2 and 3. This is vertex 1 and this is vertex 2. So this is what file C is storing. Now, again, when I come to this one, what I find is 5 to 2 is missing. 5 to 2 is missing. So now 5, 2. When I come to facet C, what I find is 7 and 5. 7 and 5 is missing. 7 and 5 is missing. Then when I come to facet D, what I find is 9 and 7 is missing. So like this, all the information is going to be stored over here. Now, once I identify that information, I will go to the new file. Which will be my file B1, which will contain information about existing edges without adjacent facets. Sorry, this is wrong. This is file C. So file C is now ready. where the vertex information is given to you. For the first edge, that is this edge, 2 and 3 is missing. For the second, 7 and 5 is missing. Randomly I have taken this. So this information has been stored. This information has been stored randomly. There is no particular sequence of doing this process. There is no particular sequence of doing this process. So randomly I have checked for all the edges. But what I have done is I have made sure that this gap that you see over here, it has got 6 edges. 1, 2, 3, 4, 5, 6. It has got 6 edges. So all the 6 edges have been properly stored over here. All the 6 edges have been properly stored in terms of their vertices. So that has been stored over here. Next, what I do is I shift to file B1. And file B1 is all those edges which do not have the information, of the corresponding edge. So now if I go back, the first edge that was missing was 2, 3. The first edge that is missing is 2, 3. So the information that is missing is 3, 2. So what I do is I change the first vertex to 3, 2. Okay, 3, 2 is missing. Similarly, for the second, it is 7 to 5. So what is missing is 5 to 7. Similarly, for third, fourth, fifth, sixth, seventh, eighth, ninth, whatever information is there, all that information has been generated. Where you find all the edges have been accounted for. How all the edges have been accounted for. So if you remember, there are 6 edges. Which are missing. So in your file B1, there should be 6 edges which are going to be taken care of. So this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So all the edges have been accounted for. So now what you do is, once you have accounted for all the edges, now you have to create a new file. This is file D. So you will create a new file D, which will actually come out from file B1. And what it will actually be doing is, it will be creating a structured order of the edges. Now, how do you create the structure order of the edge? Now, please understand this very properly. So the structured order is going to be created when the gap is a closed loop. So now what will happen is, for the first edge, you determine the first edge. You have determined it as 3 and 2. You have determined it as 3 and 2. Now for the second edge, the second vertex of the first edge becomes the first vertex of the second edge. Please remember it. I'll repeat it once again. For the closed loop to happen, the second vertex of the first edge should become the first vertex of the second edge until the first vertex of the first edge becomes the second vertex of the last edge. I'll repeat it once again, just for your understanding once again. The closed loop is going to be created when the second vertex of the first edge becomes the first vertex of the second edge, and this process will continue till the first vertex of the first edge becomes the second vertex of the last edge. So now what happens is, the second vertex of the first edge is 2. So I put first vertex of the second edge as 2. Now I check over here, where is 2? So this is 2. So I put this as the second edge, 2 and 5. Now since the second edge of the second vertex of the second edge is 5, it becomes the first vertex of the third edge. Now I check for 5 in the first edge. So 5 and 7. Now 7 becomes the second vertex of the third edge. So it becomes the first vertex of the fourth edge. So now I take this value 7 and 9. So I take 7 and 9 over here. So 9 is the second vertex of the fourth edge. So it becomes the fifth edge first vertex. So that is over here. So 9 and 11 has been taken over here. Now I check for 11 as the first edge and first vertex. And what I find is 11 and 3. So now what I can see is 3 was the first vertex of the first edge. And now 3 is the second vertex of the sixth edge. That means the loop has been completed. That means the loop has been completed. Now, once you have got a loop completed, now you will start with the generation of the facets. So now you will start with the generation of the facets. I will explain it from these examples. So now what you will do is you have created a file D over here. You have created a file D over here. File D is this structured file. This is called as file D. So once you have created a structured file D, now what you will do is you will start to create facets. So you will create a new file. You will create a new file. This is called as file D1. This is called as file D1 and this is a temporary file. This is a temporary file. Now file D1, actually it will help you to identify which vertices you are using for which facet. It will help you to identify which vertices you are using for which facets. Okay. So now what are the vertices you have? You have 3, you have 2, you have 5, you have 7, you have 9, and you have 11. So these are the 6 vertices you have. So let us create the first facet. So it is not true that you have to create facet according to my definition only. You can create your own facets also. There are many options which are available over here. There are many options which are available over here. You can use any option of the out of that. The only agenda over here is to fill this gap. The only agenda is to fill this gap. So you can use any sort of option that you feel like, but you have to remember 2 things. The orientation of the patch, the surface normal has to point outwards, first of all. And secondly, all the gap has to be completed. That are the 2 basic rules that you need to remember. The surface normal has to point outwards. Your thumb has to point outward on a surface patch and your finger depict the direction of the orientation. Secondly, the gap has to be filled. So let us take this. So what I have done is I have taken this patch 3 to 11. I have taken these 2 vertices and the direction of orientation becomes this. The direction of orientation has become this. So what I have marked is for facet 1, this is my facet 1. This is my facet 1. I have used vertex 3, vertex 2, vertex 11. Okay. I have used these 3 vertices. I have used these 3 vertices. Now, simultaneously, what you will do is you will also create a new file. You will also create a new file, file E, which will be the actual file which will store the information of the edge filling, which will store the information of the edge filling and the gap filling. So the first facet has been created. What is the first edge? 3 and 2. This is the first edge. This is edge number 1. I'm putting it in a square bracket. This is edge number 1. So first edge, first vertex is V3 and the second vertex is V2. So this becomes your edge number 2. This becomes your edge number 2, that is 2 to 11. So your second vertex is V2 and your third vertex is V11. And this becomes your third edge. This becomes your third edge. So third edge is basically V11 to V3. So first facet has covered some of the gap. So you have created one facet. Now that in the information that you need is to whether this vertex 3, will it be further used for any of the filling? No, because the facet has covered the vertex 3. So for rest of the facets you will use E. E stands for end. E stands for end. That means this vertex will not be used any further. E stands for end, which means that this vertex will not be used any further. Okay. So now what I do is, just let me remove all this. So now what I will do is I will join this. I'll join this. So a new facet is being created. So this is my facet 2. This is my facet 2. So the facet 2 is actually not going to use V3 because V3 has ended over here. I am using V2 as my first vertex. Now please remember the orientation. Please remember the orientation. Okay. So this is the orientation. So this is the surface normal position. This is the surface normal position. So now what you have to see is V2 is the first vertex, V9 is the second vertex, and V11 is the third vertex. V11 is the third vertex. So this is the gap I am going to fill now. So if I look at the orientation, so what is the orientation over here? Now see this orientation, the edge 211 and 11.2 has opposite orientability. So my solution is correct. Since 211 and 11.2 has opposite orientability, so my solution is correct. So now what I will do is I have created the second facet. So for the second facet, this is my edge 1. So edge 1 has V2 as the first vertex and V9 as the second vertex. This is my edge 2. This is my edge 2. So edge 2 has V9 as the first vertex and V11 as the second vertex. And this is my edge 3. And this is my edge 3, which has V11 and V2 as my first and second vertex. So this is how I filled my second facet. Now what remains is of the gap is this part. So this is the gap that now remains. But before that, you need to understand is check whether this vertex is going to be used any further, because this vertex has already been checked out. So now V11 cannot be used. So we put E over here. We will put E over here. That means vertex 11 has also ended as vertex 3 has ended. Now what we do is we have this gap. So what I do is I create a new word, and this is the orientability. This is my orientability. So remember, this is the orientability over here. And now this is the orientability I am testing. So this is one, and this is the other orientability. Now I'll check for the third facet. So this is my third facet. This is my third facet. So when I create my third facet, what I check is facet 3. V3 I am not going to use because that has already ended. V2 is my first vertex. V5 is my second vertex. And V9 is actually my third vertex. V9 is actually my third vertex, and V11 cannot be used because it has already ended. So my three vertices are 2, 5, and 9. For facet 3, my three vertices are V2, V5, and V9. So now I am going to create a third vertex. So now when I check for third vertex, what I find is, so this is the orientability that I am talking about. So this is my edge 1, this is my edge 2, and this is going to be my edge 3. So for edge 1, what are my vertices? V2 and V5. For second edge, it is V5 and V9. And for third edge, it is V9 and V2. And again, if I check the orientability of this edge, that is 2, 9 and 9, 2, they have opposite orientability on opposite facets. They have opposite orientability on opposite facets. Hence, my facet generation is correct. Hence, my facet generation is correct. Now, what remains of the gap, what actually remains of the gap is this part. That is V5, V7, and V9. V5, V7, and V9. So now I need to create a fourth facet. Now, as you can see, vertex 2 cannot be used any further. So that has also ended. Vertex 3 had already ended long time back. So I have V5, V7, and V9 as my vertex, and vertex 11 had already ended. So I'm going to use these three as my vertices, that is V5, V7, and V9. So this is the gap I'm going to fill. And since the orientability is in this direction, so I'm going to check against this orientability. Okay? So as you can again see, The edge 5, 9 has opposite orientability on the opposite facets, first of all. And the facet information that is stored over here is that this is going to be your first edge, this is going to be your second edge, and this is going to be your third edge. So first edge is V5 and V7. The second edge is V7 and V9. And the third is V9 and V5. So that means all the gap has been properly filled up. All the gap has been now properly filled up, and therefore the gap has been eliminated. So therefore the gap has been eliminated. So this is how you actually work with the facet elimination process.